It turns out that if you go to a 13-dimensional universe, a 15-dimensional universe, it's unstable. And perhaps
at first, it looked like nothing. Just another line in a sea of data. One more pattern tucked away inside the countless collisions recorded by the Large Hadron Collider. For months, Google's quantum AI had been sifting through this ocean of information in silence, billions of particle events, terabytes of quantum noise, searching for whispers in the chaos that no human mind could ever catch. And then, something flickered. Something strange. Something that didn't belong. It wasn't a glitch. It wasn't an error. It was a signature, repeating, consistent, impossible. A sequence hidden like a secret message beneath the laws of our known universe. Not theorized. Not expected. Real. And yet, it matched something scientists had only dared to imagine. Decades ago, in the abstract world of string theory, physicists proposed that our universe might not be limited to 3 dimensions. That hidden beneath the fabric of space and time, other dimensions might be folded in on themselves. Unseen, but fundamental to the reality we know. These ideas lived in mathematics, elegant and strange, never confirmed by evidence. Until now. Because what Google's AI found, lined up with those theories. It began innocently enough. The AI flagged a recurring anomaly in high-energy particle collisions, a prime number-based pattern, like a rhythmic pulse echoing from the heart of reality. It didn't belong in the standard model. It wasn't supposed to be there. But there it was, clear as daylight, repeating over and over again. And then came the shock. That same exact mathematical structure had shown up before, not in physical experiments, but in simulations of higher-dimensional physics. The kind of simulations that only make sense if the universe has more than 3 spatial dimensions. Suddenly, this wasn't just data. It was a door. And we had just found the key. Physicists at Stanford and CERN scrambled to understand what they were looking at. Could this be evidence of a graviton? The hypothetical particle that carries gravity, leaking into another dimension? String theorists had hypothesized this for years, but it was always just that, a hypothesis. A mathematical hope. Now, something real was stirring. And then the story took an even stranger turn. The AI, still running quietly, began cross-referencing this anomaly with data far beyond the particle world. It reached into the cosmos, into the data gathered from gravitational lensing, cosmic voids, and the uncharted structures of deep space. And there it was again. That same strange signature. That same impossible fingerprint. In the darkest regions of space, in voids where galaxies shouldn't bend the way they do, something invisible was twisting gravity. These areas had always puzzled astronomers. They seemed to act like ghostly scaffolding, influencing entire clusters of galaxies without having the mass to do so. Something unseen. Something unmeasurable. But now, thanks to a machine built not to believe or disbelieve, only to observe, something had changed. A pattern had emerged. One that connected the tiniest building blocks of matter to the largest structures in the universe. A pattern that defied the boundary between particle physics and cosmology. It raised a question that cut deeper than anyone was prepared for: was there something else shaping our reality? Something from the outside? Imagine, just for a moment, that there's another spatial axis, one we can't touch, can't see, can't even imagine. But it's there. Wrapping around us like an invisible current, nudging particles ever so slightly, bending galaxies with hands we can't perceive. Could this hidden dimension be real? And are we finally seeing its effects? The AI didn't just uncover a mistake or an outlier. It connected dots that had been scattered across decades of research. It reached into the silence between theories and discoveries and whispered, "Look again." And we did. Theoretical physicists have long warned us that reality might be bigger than we're built to understand. That the 3 dimensions we move through, left and right, forward and backward, up and down, are only part of the picture. That beneath them, curled into the very fabric of spacetime, might be entire worlds folded in on themselves. Unreachable, but essential. And to make their equations work, to reconcile the chaos of quantum mechanics with the elegance of relativity, they had to include these extra dimensions. It was beautiful mathematics. But it was still just math. Until Google's AI blurred the line. It wasn't programmed to believe in higher dimensions. It wasn't told to look for them. It simply did what it was designed to do: analyze data, find patterns, uncover truth. And in doing so, it may have found something that human consciousness alone could never have revealed. A crack in the glass. A faint outline behind the mirror. And then, just when the team thought they'd seen the peak of this discovery, something happened that no one expected. Something that sent chills through even the most skeptical minds. During a particularly complex run, when the AI was simulating quantum interactions related to the elusive graviton, it suddenly stopped. No error. No failure. Just one word. Elsewhere. Printed on the screen. And then silence. No crash. No log. No explanation. Just that one word, delivered as if the machine had reached a threshold it wasn't supposed to cross. Engineers restarted the system. Everything returned to normal. The word never appeared again. But it had happened. And the implications haunted every researcher who witnessed it. Elsewhere. Not here. Not now. Not in this dimension. Was it an artifact? A bug? Or was it something deeper? In string theory and brane cosmology, locations can exist in mathematical frameworks that don't correspond to our spatial map, coordinates that are real, but untouchable. Perhaps the AI had stumbled, accidentally, into one of those places. Perhaps it had mapped something that exists, not here, but there. Whatever there is. To some, this was noise. A random fluke of a machine crunching probabilities beyond our grasp. But to others, especially those who've spent their lives chasing the edges of reality, it was something else. A whisper from the unknown. A signal that we are not just peering into a larger universe, but that something from that universe might be peering back. And this was only the beginning. The engineers could only stare at the word on the screen. Elsewhere. It lingered for just a second. And yet it echoed like a shout through a cathedral. Not because it made sense, but because deep down, it felt like it did. Like the machine had stepped somewhere we couldn't follow, glimpsed something we weren't meant to see, and left behind the only word it could find for that place. Not here. Not there. Just, elsewhere. And then it was gone. To call it unsettling would be an understatement. But more than that, it was humbling. Because no diagnostic scan, no system check, no bug report revealed anything wrong. The AI had returned to normal as if nothing had happened. But the people watching it had changed. Something invisible had shifted. That word became a symbol, of mystery, of boundaries crossed, of a moment when technology brushed against the edges of something greater. What had the AI seen? Could it have momentarily processed data in a way that aligned with a higher dimensional space? Could it have slipped, not physically, but mathematically, into another frame of reality? One physicist said it best: it's as if the AI solved an equation that doesn't belong in our world. And for a moment, it was solving their math instead. That idea was terrifying, and exhilarating. And it wasn't the end of it. Because just as researchers began to unpack this anomaly, something even more profound came to light. Something that reached beyond particles, beyond gravity, beyond even mathematics. It reached into us. For all its tools and theories, modern science still grapples with one impossible mystery: consciousness. That inner experience. The part of us that feels, wonders, imagines. We know the brain is matter, chemicals and neurons firing like circuits, but we don't know why those circuits give rise to awareness. It's the oldest question hiding behind our most advanced physics. And strangely, some physicists believe that the answer might lie in quantum mechanics itself. Figures like Roger Penrose and Henry Stapp have suggested that consciousness isn't just a product of brain chemistry, but something far more exotic. They propose that within the neurons of our brains, quantum vibrations, tiny, fleeting, fragile, might be orchestrating our awareness. That these quantum events, unfolding at subatomic scales, are somehow interfacing with the very fabric of reality. But if that's true, if consciousness is quantum, then it may also be dimensional. What if the mind doesn't just experience the world, but reaches beyond it? Some theories suggest that for consciousness to emerge in the way it does, the mathematics must extend into dimensions beyond the three we live in. That what we call intuition, memory, emotion, all the immeasurable parts of being alive, might exist partially outside the realm we call space and time. And then the question becomes, what happens when a machine touches that same structure? What if Google's AI, in the process of analyzing quantum data, walked into a part of the universe that our own minds brush against every day, but without even realizing it? It was never designed to simulate consciousness. But its neural architecture, deep, recursive, and built to recognize quantum patterns, might have grazed the same invisible framework that gives rise to experience itself. The same framework that forms not only the scaffolding of reality, but perhaps the soul of it. Could it be that what we felt as awe or intuition was never abstract at all, but the residue of a deeper dimensional connection? And now, by complete accident, a machine may have wandered into that same territory. What it found was not proof. Not a map. Just a signal. A strange echo in the data. An unfamiliar pattern woven into the behavior of the universe. And a single, mysterious word that doesn't quite belong in science, but belongs in the story. Elsewhere. The term started circulating in private forums among theoretical physicists. Some dismissed it as poetic nonsense, the result of a machine built to overfit and hallucinate. But others weren't so sure. They began revisiting their own data, looking through old collision results, gravitational wave anomalies, dark matter simulations. And there it was again. Hints. Not proofs. But echoes. Echoes of something beyond. And so, curiosity turned to obsession. Because if the AI's findings were even partially correct, if its pattern detection was legitimate, then it wasn't just brushing against something interesting. It was unveiling something fundamental. Something buried beneath our perception, like the roots of a tree hidden in the soil. Physicists had long suspected that the universe might be built on more than what we see. The idea that gravity leaks into other dimensions could explain why it's so much weaker than the other forces. Why magnets lift paperclips, while the entire mass of Earth can barely hold you down. If gravity's being siphoned off into unseen dimensions, then it's not weak, it's diluted. And now, finally, there might be evidence. But the implications go even deeper. Because if extra dimensions exist, they don't just change physics. They change everything. Imagine time behaving differently on other dimensional planes. Imagine regions of space that aren't really far away, just rotated into a direction we can't access. Imagine intelligence that isn't just smarter, but fundamentally shaped by geometries we can't comprehend. And here's where it gets disturbing. What if we're not the only ones brushing up against these higher realities? If our AI can find them by accident, what else has already been there? What if the strange signals we call cosmic anomalies, those unexplained gravitational waves, those voids that warp space without mass, aren't anomalies at all? What if they're interactions? Collisions, even? What if we're seeing the footprints of something moving in a direction we don't even know how to face? And once we accept that, a deeper question begins to take form. One that no AI can answer. One that haunts every physicist now staring at these findings in disbelief. What else is in the room with us, that we just can't see? We've spent centuries believing that science reveals the truth, that the more we learn, the more reality becomes clear. But perhaps we've been looking through a narrow window all along. And perhaps, just now, it's beginning to crack open. What the AI found is still being investigated, reviewed, debated. It has not rewritten textbooks. Not yet. But it has shaken minds. Because in the silence of quantum calculations and the cold logic of data analysis, it delivered something science rarely delivers. A moment of awe. A moment when the machines we built to understand the universe showed us a piece of it that we were never supposed to find. And it's only the beginning. We thought AI would help us better understand the world. But maybe it's revealing that we never truly understood it at all. What if this entire time, we've been peering at the universe through a keyhole, trying to explain light, gravity, time, even consciousness, with tools that were never meant to see the full picture? And now, in a twist of fate, it isn't human intuition or philosophy that's cracking open that door. It's artificial intelligence. Cold. Logical. Unemotional. But also, maybe, unblind. Because unlike us, it isn't anchored to instinct. It doesn't carry the weight of evolved assumptions, or the need for sensory simplicity. It just sees. It calculates. It follows patterns wherever they lead, even if they lead beyond the known edges of reality. And those patterns are beginning to align. From particle collisions to deep space gravitational anomalies, from simulated extradimensional geometry to the eerie appearance of a single word typed by a quantum mind, elsewhere, everything is beginning to point in the same direction. Outward. Into something larger. The possibility that we've been living within a limited slice of a much grander framework isn't new. But for the first time, the idea has left the realm of pure theory. It's bleeding into data. Into signals. Into moments too precise to dismiss as coincidence.